We're going to go ahead and take a look at rational functions and graphing rational functions. A rational function is defined to be a polynomial over a polynomial. Make sure that you know that a rational function is a polynomial over a polynomial. So now, go to your calculator, go ahead and graph this. So go to the y equals, if you type it in without the fraction feature, go 1 divided by parentheses x minus 2. If you do have the fraction feature alpha y equals, go ahead and use that. And then graph it. However, I want you to graph it with this. So hit zoom, that's the top center button. Hit decimal. Hit graph. Now we're going to go back to window. We're going to change your y min to 0, your y max to 8.2. Then go ahead and graph that. If you do that, you should get something that looks like this. So in other words, we have a vertical asymptote right here at x equals 2, which we knew we could not use 2 because if x was 2, we get 0 on the bottom, and remember, you can never divide by 0. We also have that occurring over here. So do we get a vertical asymptote here at x equals 2? Well, let's go ahead and graph f of x. So go back to your y equals. If you're not using your fraction feature, put the whole top in parentheses, then hit divide, the whole bottom in parentheses. Or if you are doing the fraction feature, alpha y equals, type in the top, arrow down, type in the bottom. Your window should already be set for this, so you should be able to just hit graph. Oh, sorry, I messed up. When you're graphing this first one, just graph it on your basic window. Graphing the second one is when you have to hit zoom, decimal, then change your y min to 0, your y max to 8.2. If you do that, you get a missing spot in your graph right here when x is 2. You don't get a vertical asymptote, you just get a missing spot. We call that a hole. So why don't they both have a vertical asymptote there? Well, if you look at the second one, the top factors and the bottom factors, now you'll notice you actually do have a common factor top and bottom here. When you have a common factor like this, that ends up giving you what we call a hole. Over here, on our first one, we did not have any common factors in the top and the bottom, so there's no holes. So what causes the bottom to be 0 on the first one's a vertical asymptote. Since we had a common factor top and bottom, that gives you a hole, a missing piece of your graph. By the way, if you would cross out your common factor here, it leaves you with just an x plus 2, which you should know is a diagonal line, slope of 1, y-intercept of 2, and that appears to be what it is. And so it's just a line with a missing spot at 2, and we knew we couldn't use 2 because that caused the bottom to be 0. So when you're looking at rational functions, a lot of times rational functions will have vertical asymptotes, and that's what causes the bottom to be 0 of the simplified function. So basically, if you had factored this and crossed out your common factors, if you still had variables in the bottom, they would give you vertical asymptotes. Holes occur when you have a common factor in the top and the bottom. And how do you find that hole? You look at what causes that common factor to be 0. You also need to find the y value of that hole. How do you find the y value of that hole? You plug the x-coordinate of your hole into your simplified function. Rational functions will often have a horizontal asymptote. Sometimes they'll have what's referred to as an oblique asymptote. Basically, it's what happens when you go far to the right and far to the left in your graph. If your graph levels out at the same height going left and right, it has a horizontal asymptote. So we want to go ahead and help us understand this so it helps with horizontal and oblique asymptotes. This right here basically means What happens to our expression when you plug in a really, really big number? Because it says x is going towards infinity. Well, if you're plugging in really, really big numbers over here, you really just have to look at what's most influential and powerful on the top, which is your 3x cubed. Because when you're plugging in big numbers, your 7x and your minus 1 won't do much. And you look at what's most influential on the bottom, which is x. So you look at most influential over most influential. In this case, it simplifies down to this. Now remember, we're plugging in really, really big numbers here for x. Something really big squared times 3 is even bigger yet. So it gets really big, bigger, and bigger. So it does not approach one particular number. So there is no horizontal asymptote. You would have a horizontal asymptote if this would approach a number right here. So down here, we look at what's most influential on the top, what's most influential on the bottom. In this case, it's 3x cubed and 5x to the third. So we're going to take our 3x cubed over our 5x cubed. In this case, it does simplify. Your x cubes drop. We get a number. So we would have a horizontal asymptote of y equals 3/5. Down below here, we do the same thing. Look at most influential over most influential, which is our 3x cubed over our 5x to the fourth. This does simplify down. We still have an x left, so you got to think, okay, if I start plugging in really, really big numbers, it would be 3 over something really big. 3 divided by something really big is close to 0. So we would have a horizontal asymptote of y equals 0. So if the top has a bigger power than the bottom, we have no horizontal asymptote. If they have the same degree, we have a horizontal asymptote of y equaling a number other than 0. However, if the bottom has a bigger power than the top, we have a horizontal asymptote of 0. And that's what we're talking about here. Y equals 0 if the top has a smaller power than the bottom. Y equals a number other than 0 if they're the same power, top and bottom. And then if the top has a bigger power than the bottom, then there's no horizontal, but we would say it would have an oblique, and we'll be getting to an oblique asymptote here. So just beware, you might want to write that it will be an oblique asymptote. So in graphing rational functions, we want to do all this stuff. Find our domain, basically look at what causes the bottom to be 0, and your domain's going to be all real numbers other than that. You want to find your holes. Once again, you want to factor the top and the bottom, and holes are when you have common factors. Vertical asymptotes are what causes the bottom to be 0 after it's been simplified. Y-intercept is when your y value or your x value is 0 because you're not left and right. Your zeros or x-intercepts are when your y is 0 because you're not up and down. Then you want to check to see if you have a horizontal or oblique asymptote. That's what you get when you plug in really big numbers for x. And that's what we were doing right here with this and on the previous slide. Then you want to go ahead and plot all that. Plot your hole, plot your vertical asymptote, plot any horizontal asymptote, plot your y-intercept, plot your zeros, and then you can put it into your calculator and hit graph. So we want to find all that information for this particular problem here. So we want to find our domain. Well, domain is pretty much what you get when you factor the bottom. So you factor the bottom. Domain's going to be all real numbers except what causes the bottom to be 0. Set this to 0, set this to 0, so your domain's going to be all real numbers except x cannot be equal to -5 and x cannot be equal to 2. Then we could go ahead and try to find any holes in vertical asymptotes. Well, once again, holes are when you have a common factor, so you also have to factor the top. Factor the top, you get this. Notice we have a common factor on the top and the bottom right here of an x plus 5. So what causes that x plus 5 to be 0 is this here. That's a special form of 1 of x plus 5 over x plus 5, so we can work with just what's left, which is our simplified function right here. To find the y-coordinate of our hole, we take our x-coordinate of our hole and plug it into our simplified function. So the coordinates of our hole are this. Now looking at your simplified function, what causes the bottom to be 0 would tell you any vertical asymptotes. You can have more than one vertical asymptote. So you got to work with your original when you're looking for domain and holes. Everything else you can do from your simplified version. So if we have this right here and we're looking for our y-intercept, your y-intercept is when x is 0. So if we plug in 0 here, plug in 0 here, we end up getting -2. Now whether you plugged it in here and here or plugged in 0 to your original up here would not make a difference. Looking for your zeros, which is when your y is 0, you put 0 here, 0 equaling your fraction. The only time a 0 is equal to a fraction is if the top is 0. You set the top equal to 0, solve it, and you get x to be -2. So we cross the y-axis at -2, we cross the x-axis at -2. We have a vertical asymptote at x equals +2. We have a hole at the coordinates -5, 6/7. We can plot all that. And then we also need to go ahead and find a horizontal or an oblique asymptote. Now, as you look here, you'll notice you have the same power top and bottom. So that means if you have the same power top and bottom, it's going to be y equaling a number. Pretty much you take most influential over most influential, so 2x squared over x squared, that simplifies down to 2. So we get a horizontal asymptote of y is equal to 2. So plot all that stuff. Horizontal asymptote of y equals 2, vertical asymptote of x equals 2, our y-intercept of -2, our x-intercept of -2, and our hole. Now go ahead, put this into your y equals. If you don't have the fraction feature, put the whole top in parentheses, hit divide, put the whole bottom in parentheses. And if you want, you can always go second graph and look at your table to get accurate points. And then you should be able to get this purple graph here. So for the most part, that's what you need to do to be able to go ahead and graph a rational function. We have another one to do here, but we're going to touch base on oblique asymptotes. Whenever the top has a higher power than the bottom, then it's an oblique asymptote. An oblique asymptote is just a curve that your graph gets close to as you go far to the right or far to the left. You'll notice on this one here, because the top has a higher power than the bottom, we will have an oblique asymptote. Your oblique asymptote is your quotient after you divide. Longhand division will always work, but because we're dividing by x plus a number or x minus a number, we could go ahead and just use synthetic. If we did synthetic division, put down what we had on top, work it out. Remember, the last number is your remainder. We're only concerned about the quotient. Y equals the quotient is your oblique asymptote. So we get y is equal to a 2x plus 3. So now we got to still do all that other stuff. We got to find our domain, so we factor the top, factor the bottom. Your domain's all real numbers except what causes the bottom to be 0. You'll notice we have no common factors top and bottom, so we have no holes. So what causes the bottom to be 0 is your vertical asymptote. So that's x is equal to 2. Your y-intercept is what you get when you plug in 0. Now, whether you plug in 0 here or up here would not make a difference. If you plug it in up here, you get negative 3 over negative 2, or 3 halves, which is 1.5. Your zeros is when your f of x, your y value, is 0. And the only way a fraction is equal to 0 is only when the top is 0. So what causes this to be 0? That's negative 1. What causes this to be 0? Well, you'd have to add 3 divided by 2. And so then you get 3 halves. So you now want to go ahead, plot your vertical asymptote, plot your y-intercept, plot your 2 zeros. And then you want to go ahead and draw in your oblique asymptote, which is a diagonal line with a slope of 2 and a y-intercept of 3. So plot at 3, then do your slope up 2 over 1, up 2 over 1. Draw in your oblique asymptote as a dotted line. If you do all that, you should get this. Your oblique asymptote, your vertical asymptote, your zeros, and your y-intercept. Notice my scale is probably different than yours, and that's okay. Now you want to go up here, put this in your y equals, put the whole top in parentheses, put the whole bottom in parentheses. You can always hit second graph to get your table, to get accurate points. But when you do that, you end up with this shape in purple.